Hey, how's it going, guys? My name's Daniel, aka HashLips, and welcome back to the year 2022, where we are going to kick off this series with a lower gas NFT contract. I hope everyone had a great festive season and welcome back. Like I said, this is going to be a great year for education in the NFT, blockchain, and coding space. If you're new to my channel, I teach people how to code, specifically focusing on blockchain technologies. So in today's video, we will be focusing on a smart contract that's used to create NFTs, but this time focus on more gas efficient ways to create NFTs. Now, if you are new and you want to start your own NFT collections, I highly recommend watching some of my other videos, particularly this ultimate guide, as well as some other ones if you are interested in how to generate NFTs. Although I have a lot of content on the subject, these 4 videos over here will tell you the true tips and tricks of the HashLips art engine. This is a piece of code that I've written that is convenient enough for you to take layers and generate thousands of images with it. I am sure you're going to have lots of fun, especially if you follow this ultimate guide and these 4 videos. You'll have a good understanding of how to create NFTs, and along with this video to show you how to save people who want to mint your NFTs on gas, it is just a good recipe. Let's get going, let's look at the contract, and let's jump right in. You can find this contract that we are going to be discussing today on the HashLips GitHub repo, particularly the repo saying HashLips_NFT contract. Now there's 2 ways of accessing it, and if you are watching this video on a very later stage, I would highly recommend to go to this releases and click on release version 1.0.1. Once you do so, you can actually download the whole source code and exactly find the contracts folder in the same space. Seeing that this is relatively new, I can simply just access it by going on the main branch, scroll down to the contract section, and then in here you will find this simple NFT lowergas.sol. Click on that and let's go through the code. Right here at the top you can see 2 things. First of all, you can see who helped contribute to this repo, Liarco, or otherwise known as Marco. Now, Marco is actually a great developer and he helped me. We sat through this contract working out what's the best way to save on gas. Now, I have to give credit because I'm going to involve Marco and other devs more and more in these videos that I create, simply because I want to provide the best content for you guys. Now, thank you, Marco, and I hope you're watching this and that you have a smile on your face because we had some great fun creating this as well. Secondly, we have a disclaimer here at the top that is on all of our contracts, and the reason is we are an educational channel and we purely show you guys this for educational purposes. Please do not use this for production if you haven't fully tested and are happy with your code. This is just to cover ourselves and also to make sure that we can provide you content without worrying too much if we make a mistake. We do try our best to test the contracts to the fullest of our abilities. So that being said, let's move on and see what changes we have made to this new contract. I think it's important to note, if we just jump quickly back and we go to the simple nft.sol contract, this is the actual contract that we adapted. I think it's important for me to jump between the old contract, this one, and the new one to show the changes that we've made so you fully understand that some of the changes were more cosmetic and the others were very necessary to get the gas lower. I was informed by Marco that he took the initiative of reading through this article, explaining nicely and going into depth of why the total supply and the IEnumerable kind of interface, they instead used a counter. Now you can go into depth, and thank you to the authors of this article for writing this. It's a brilliant article, so if you want to learn more, go and check it out. For now, we can jump back, and like I said, the IEnumerable. What is this? Well, if we look at the old contract, this is where it all starts. We have 2 imports. We have the IEnumerable interface, and we also, well, the actual contract, and then we also have the ownable from OpenZeppelin. This is the one that causes the gas to be quite high. Now, what we've done in the new contract is we took it out altogether. Instead, we are now making use of the ERC721 contract directly instead of the IEnumerable one, and then we are using counters to keep track of how many NFTs we have. This eliminates the fact that we have to base ourselves or base this contract on IEnumerable, making sure that we don't have to deal with mappings or arrays or more complex structures. We are still making use of the ownable contract, and for the rest we have made some updates. So let me walk you through. Here at the very top, we declare that we're going to use strings for UN256, making it easier to convert, as well as initializing our counters. Telling this contract, we'll be using this contract. On line 28, we actually create the variable, a private variable called supply. Now it's private because we do have a getter function called total supply. We'll show you how to get to that. Then we have our other functions. Previously, this URI prefix was called base URI in the old contract. We have now updated this to turn it into URI prefix and URI suffix. This makes more sense, seeing that this is the metadata. It pushes some element or ID in between and then adds the .json part. The reason why the suffix is separate is so that we can actually change it if we want to go for an API instead. The rest is quite simple and you might find it quite familiar. We have the hidden metadata URI, which also has changed. It's a better naming convention, seeing that you have to supply the whole metadata string. Then we get to the cost, our max supply, the total amount of NFTs that we will have, and then also the max mint amount per TX. This name is way better than the previous one, which was just called max mint amount. This is better because it means that someone can mint up to 5 NFTs per transaction. We also have our paused and revealed like the old contract. Something that changed in the constructor is that I'm not passing in constructor arguments. Instead, I'm passing the name and the symbol directly, along with the first hidden metadata string which needs to be replaced. The reason for this is so that we don't find it difficult to verify our contract on Etherscan, and it's a way better step to do because you don't have to provide the ABI encoded data that's provided with the constructor. I'll show you that once we've deployed this contract. Before we carry on, I would like to say I missed you guys so much this festive season, so leave me a like, subscribe if you haven't, and if you're enjoying this content, leave me a comment below, either saying hi or if you have a question. You can also suggest some awesome videos that you would like me to make, and I'll do that. Moving on, we now have a modifier called the mint compliance. This just makes sure that the parameters that you are minting these NFTs in stays in the boundaries of the max supply and also the max per TX. So that's all it does, and we apply these now to our two minting functions. We've got two minting functions, the normal mint for people, as well as a mint for address, which is only callable by the owner. Here you can see we're applying the mint compliance to each one of these functions. If you want to learn more about these methods that I'm using, as well as how to apply modifiers, feel free to go to my channel, and I do have a nice playlist on Solidity basics right over there. You will get to learn a lot, as well as if you need to know how to do stuff on IPFS, you can check out this as well. We are going to be skipping the IPFS step once we deploy this contract, so feel free to watch this IPFS video before we get there. So the modifiers help because it reduces the amount of code that we have to write. Instead of duplicating this line in each one of these functions, we use modifiers. We also have this total supply function, which is now replacing the IEnumerable function that we have to implement to get the total supply. This simply returns this counter supply.current and gives us the current value of how many NFTs we have minted. The two minting functions work quite differently, but the only difference is that the normal mint for customers, I would say, asks them to put in a mint amount. It checks that the contract is not paused, as well as requires them to have the amount or the sufficient funds for minting the amount of NFTs. When you look at the mint for address, the owner has access to this. Therefore, they are not hindered by the pause contract, as well as they do not have to pay to mint the NFTs, because sometimes owners need to do giveaways. That being said, owners still have to have the mint compliance modifier attached to this function. This is so that the owner can't overmint over the max supply. Then we have the wallet of owner function. This function, all that has changed is basically this while loop. Now, what does this function do? It returns an array of the token IDs that someone owns. To find these IDs, we use a while loop instead of a for loop. And this is to save on gas because as soon as the while loop has found all of the items, it will stop execution instead of a for loop which will run through the whole collection itself. Moving on to the token URI function, this function for the most part has stayed exactly the same as the old contract. So has all these update functions below, which is only callable by the owner. As you can see, one change is the set revealed. We have updated these names to make more sense, as well as allowed the freedom to unreveal the contract as well. Keep in mind, once a contract has minted out and everyone has their NFTs, it makes sense for the owner to renounce from that contract. This just makes the contract way more secure. But while minting is taking place, and if the developer so needs to update or fix something, they can by using these functions. Let's go through them. As I mentioned, we get the set reveal, which just allows the developer to hide and unhide the metadata. Then we get the set cost, very straightforward, but keep in mind, people get stuck because when you use this on the outside or after your contract has been deployed, when you update the cost, you will need to provide a WAY amount instead of an Ether amount. This simply means that you need to use, instead of 0.01 Ether, you will need to use 1 with the 18 decimal trailing zeros, because at the end of the day, in contracts, we use WAY. Now, we also get the max mint per TX, so max mint amount per TX, which means that you can update it. It simply takes an integer. This function over here, set hidden metadata URI, takes in a string and updates the hidden metadata if you made a mistake. We then have the set URI prefix as well as the set URI suffix. This function is mainly used after you have minted out or before you reveal the contract metadata. You're going to update the prefix and then you're going to reveal. I will show you that once we deploy this contract. Lastly, we get the set paused. This is the very first action that you'll do once you open up the contract and have people mint your NFTs. For the last few functions, we have the withdraw, which is only callable by the owner. Now, this is quite special because this function shows you how to do a small payment splitter if you had an extra team member. Currently, I've got my address in there, so if you want to deploy a contract and leave it in here, you will essentially give me 5% of all the initial mints to say thank you for me showing you this awesome content. But I don't mind if you want to take it out or put someone else's address in there. Just keep in mind that you always need to leave this bottom one in there. Please do not remove this, otherwise you will not be able to remove the funds from your contract. If you want to keep 100% of all the profits, which is perfectly fine, you can remove this part up here. But keep in mind that after you've removed this part, that this part is still in here. Because one of these, or not this one, but this one over here, technically says that it puts the remaining balance into the owner's wallet. We have then moved the mint function outside and the for loop for minting into its own separate function. This is to do with the minting that's happening at the top. But because these are internal functions, we've moved them here down to the bottom. Lastly, we get the same underscore base URI, which just returns the base URI. And that's it. That's the whole contract. Now let's go and deploy this on the test network and see how it works and check our NFTs on OpenSea. Before we run off and deploy this contract, you at least need to know where are we saving gas. Now the IEnumerable functions or the contract basically contain the total supply function. And we are now self-implementing this using our counter. Now we also, when it comes to minting, using the underscore mint loop, which we've implemented here at the bottom. Something important to note is that we are incrementing our counter before we do the safement. This ensures that it's safe, as well as we keep track of how many NFTs we have in our contract. That is a basic change that will help you save on gas when it comes to minting. Now there's another way of saving gas on OpenSea and some more nuances we can do in contracts, but this will add step by step so that you get to learn about Merkle trees and proxies and as we go along on our Solidity journey. For now, we're going to go ahead and deploy this contract. So the next step you can do is actually copy everything inside this file like this, or you can simply click on this function over there or this button over there. Next, go to remix.ethereum.org, an online Solidity compiler, which is great to use. It looks like this. Then you can go ahead and create a new workspace. It looks like this, and we can simply create a new contract. I'm going to call this lowgas.sol. Then I'm going to paste everything I have from that contract in here. You should see OpenZeppelin dependencies being imported immediately. After that, you will see a green tick, and you can verify that everything is working. We can see that the compiler is using a 0.8.7. Now that's fine because it falls in our range over here. And then I usually go and flatten this file to pull in all the dependencies into one single file. You don't have to do this step, but then you need to upload each file independently. So I don't want to do that, and I'm going to flatten it. So let's just type in flatten, flattener. I'm going to activate it. You'll see the script pop up on the left hand side. Click on that. Make sure you're on your contract and click there. Then it's going to ask you to save. Just say yes. I usually turn that on and accept. This is now our flattened file, but we can see there's a warning. Now, if we try and find this warning by just making sure we are on this low gas flat, you can see it's there at the very bottom. And if we click on it, we can see that there's a warning and it tells us that we don't have a specified license. Let's go to the file system, go and find our low gas contract and just copy our license over there. Go back to the flattened file, and then I'm simply going to paste it up here. This should work, and now we have our green tick again. Now we're ready to deploy our contract. We can now move over to the deploy and run transaction section and make sure that you are on the lowgas_flat contract. Before we deploy, we need to make sure that the variables that we want is set in place. So scroll down to the actual contract there where we can actually set all the variables right over here. We can give this contract a new name, and let's call it maybe sketchy ghost space. Who knows? Sketchy ghost space. Then I can go ahead and select a symbol, which would be SGS, like so. So now we've got our sketchy ghost space, and we need some kind of hidden metadata. Remember when I told you guys that you can watch the IPFS video, and after you've watched that IPFS video, you will end up with metadata like this. I'm going to go ahead and take this section over here, copy it, then go back to my contract. It's important that I only replace this part over there and keep the IPFS ://. If you want to follow best practices, you need to call the contract over here the same name as your Solidity file. For now, I'm just simply going to maybe turn this into the sketchy ghost space, like so, contract, and I'm not going to change the file name because I still wanted to say low gas flat because we're going to do a comparison test. But best practices tells you that you need to call it sketchyghostspace.sol if you are using it. Next, make sure that you are happy with the price and the cost of your NFT. This is per NFT, so just work out a nice price. I'm going to make a supply not 10,000 but 20, just to keep this simple. Then max mint, I can maybe leave at 5, it doesn't matter, or lessen it to 3 or even 2, maybe even 1. But it's most important that you don't go over 20 and above. Just keep in mind that a smart contract doesn't do well with a lot of computation, so keep it in small little chunks. We are now ready and set to rock. We can deploy this contract and test it out. So let's go ahead and deploy this. Like I said, make sure you're on the deploy and run transaction section. We are going to do this through the injected Web3 provider, making sure that we have a MetaMask set up on the Rinkeby test network. On a side note, if you get stuck and you don't know how to set up a MetaMask account, how to add test ether through a faucet, or even change the RPC, you can feel free to go to the HashLips.online website, go to our Discord community, and actually join. There are thousands of devs and artists that's willing to help you out with these smaller things when it comes to NFTs and how to deploy your own contract. Let's get back and let's deploy our contract. Awesome. So now we can go ahead, select contract, and we need to make sure that we have selected the _flat low gas.sol. Once we've done that, you can see there's no input parameters or constructor arguments that we need to provide. That is because we've entered everything in here. This will make it easier for us to verify the contract in the next step. Some things to double check is when you select the contract, make sure it's not on the strings. However, the sketchy ghost space or the one that you called it. Otherwise, you'll be deploying just a fragment of the contract. Then go to MetaMask and make sure that your MetaMask address on the Ethereum Rinkeby network, the test network, says connected. Once that is all in place, click on deploy. This will bring up a transaction from MetaMask, which you can simply then say confirm, and we will then wait for our transaction to be completed. On a side note, if you are ready with your contract and you want to attempt deploying this on the main network of Ethereum, you can simply change the MetaMask RPC, the network up here, to the Ethereum main network. For now, do your test on Rinkeby and first test it out properly. You can see that our transaction was successful. If we expand the logs, what happened, we can see how much gas it actually took to deploy our contract over there. We can also see an instance of this contract on the left-hand side if we expand it. If we copy this address and go to the test Etherscan, not the real Etherscan, because remember, this is the test network we're dealing with, we can now go and check out our contract. So make sure that you copy this address over there, or it will also show up in your logs. Now, after you have copied it, go to the test rinkeby.etherscan.io. Go and search for that contract and click on the search icon, and this will bring up your contract over here. Now, very important, always verify your contract so you can interact with it on a later stage on Etherscan. I'm going to click on contract, then verify and publish, and although this is on the test network, it's a great place to test what will happen on the real network. It's going to ask us to verify and select the compiler type. Well, the file that we compiled. So we have to select single file because remember, we use the flattened file. Then it's going to ask us the compiler version, which we use 0.8.7. We can then select the license, which is MIT, agree to the terms and conditions, and click continue. Once we do that, it's going to ask us if we have optimized our contract, which we haven't, and then the contract code. It also needs the ABI encoded kind of data, but we can actually remove this because we had no constructor arguments. So remove that, go back to your contract, simply select everything and copy the whole contract, go back, paste it in this space like so, then scroll down, verify that you are not a bot, and now we need to kind of select some chimneys, which I think that's fine, and some traffic lights like so. And then once we have selected more mountains like so, that looks fine, then we can verify and publish our contract. Geez, I hope they know I'm not a bot by now. This takes a second or two, and what will happen is you should get a green tick saying that we now have verified the contract, and this is great because now we will be able to interact with our contract on Etherscan. You can see it was successful. So if we go back to the contract now, we will be able to see our contract over there. We can read from the contract as well as write to it. After verifying a contract, you don't need to use Remix anymore because now your contract is on Etherscan. Although this is the test net, you can do it on the real net just like this. But you can go to the contract, write to the contract, make sure that you connect to it via MetaMask with the owner's wallet, which is very, very important. And I'm not sure that this is the wallet that I used. So let me actually go to this one, number 5. Let's say connect. All right, there we go. Let's maybe refresh this page so that my ID can change. And once I connect now, I can see this is the correct address. The first thing that I'll need to do to be able to mint is set the pause to false. Once I do that, I can click on write, and then I'm changing the actual logic of our contract. So let's go and have a look. If we go to the read part, we will be able to see if this contract is now paused and it says false, meaning that we will be able to mint. Now I'm going to go back to the write function or the tab and actually mint an NFT. I'm simply going to use this one, and for the payable amount, this time I need to provide 0.01 because I think that's the price. And over here I'm going to mint one NFT. I'm going to click on mint and then have it tell me what the gas is going to be and say confirm. This is important because I want to see this transaction taking place because I want to show you guys the gas savings that we have. After unpausing the contract and then minting my first NFT, what happened was the NFT was minted and now we can see actually a tracker name as well. So this is very nice. I'm going to try and mint another NFT just to make sure we mint some more. So I'm going to do that, and then let's do another one, and we write to it. We need to be connected, so make sure we're connected. Click on write and then allow this. This is awesome. One thing that's very important now is to go to the transactions and let's refresh this. We can see that we've got 0.2 Ether in the contract. We've got 2 mints taking place. But the most important thing is if we go into a transaction and scroll down, we can click on more and we can see the amount of gas used. Now, normally this will be way higher. And this is 66,000 gas limit that's been set. And this is obviously now not real prices. But to give you a comparison, this is about 33% of a normal mint with an IEnumerable contract. So you're saving about 70 to 50% depending on the time or the contract behavior on each mint. And the more you mint, the more you save as well. So this is just superb. Apart from having a killer cool contract right now, we can go ahead to OpenSea, specifically the testnets.opensea.io. Make sure that we have our profile connected to the testnet. So I need to probably connect my new account that I just created. So I'm going to say connect. And then once I've done this, I can go ahead and refresh it and then get to my profile. Now, I don't want you to panic at this stage that your NFTs are not showing up on OpenSea. Please give this at least 12 hours or whatever it might be, because OpenSea testnet is a bit slower than normal, I've realized. And at first it didn't show up, and then the next day for me I came back and there my NFTs were. Now these will have the hidden metadata and they most probably will look hidden. How do we change that, and how do you update the token URI to be something like this? Now once you are ready to reveal, go ahead and copy this part. Well, not this one. You need to do your own metadata. Like I said, watch the IPFS video. You can go back to the contract and go to the write functions. After you have connected like normal, always make sure you connected to the correct address. Now, usually members will mint their NFTs and they'll see them on OpenSea, but it should have hidden metadata, maybe displaying some kind of question mark on their NFT because they don't know what it's yet. And to reveal that NFT, what you can do is before you click on the revealed or before you set the revealed, you have to set the URI prefix. So first go here and type in IPFS : / and then this. Remember to put the CID and leave a trailing /. This is because this is the prefix, and technically the contract will enter the ID and then our suffix will be added to the end. So I'm going to write this to the contract. Then after you've done this part, you make sure that the transaction is successful first. And then once it's successful, you can then go and set the revealed to true. And it's as simple as that to kind of reveal the real metadata to your users. So to reiterate, once you have your artworks ready on IPFS, your metadata, as well as your images, then you go and deploy your contract, most probably on the test network first. Then you can do the same steps, but this time deploy it on the main network. Once you are ready to start minting, please remember to unpause your contract like so, and then people can start minting your NFTs. Once it's time to reveal the actual metadata, what you need to do is update the URI prefix first and then go and reveal. That's just generally the steps that everyone takes. I have to add a big thank you to the Sketchy Ape family. Now, for those of you who don't know, Sketchy Ape Book Club is my collection that I started with our huge marketing team and a lovely family of community members coming together to write the very first NFT-based book written in a collaborative venture. These NFTs are all hand-drawn by myself, so if you want to go and check it out, go and check it out. It is pretty cool. We are still minting. 50% has now minted out, so they're going quite fast. Anyway, till next time, I hope you guys enjoyed this video on learning with me, as well as me showing you how to make this gas, or lesser gas, let's call it, contract. There will be many more videos like this, and we are going to always improve on it. If you have suggestions for my videos, please drop a comment below. Like I said, don't forget to like this video, and I'll see you in the next video. Cheers for now.